Alright, so guys, welcome to the first episode one of our physics 101 class. So we have our first question. So the first question is stating that we should compute the force that exists between two protons. Now when we say protons, we are looking at positive charges, right? So two different protons, proton 1 and proton 2, and they are positively charged. Now since the protons, they have like charges, protons, they have two positive charges and they have like charges, so it simply means that they will repel each other. So the force we are going to be having, we'll be having a repulsive force. So we have the value for K, we have the value for Q1, and we have the value for Q2. Similarly, we also have the value for R and all of this. So what they want us to find is to find the force between these two different protons. So when we compute the necessary applications, necessary parameters, you arrive at the final answer of the force. So that's the final answer for the force between the two protons. So for the second question is the dipole moment. So if you have dipole moment is given as P. Sure you get, and dipole moment is given as P equals Q multiplied by what? By the separation of the two charges. So that's the distance. That's the separation of the two charges, is simply referring to as the distance between the dipole moment of the electric dipole. So but we're already given that the distance is 2a. The first distance is going to be a, the second distance is going to be a. So when you add the two distance together, you have the distance to be 2a. So our final dipole moment will be equals to P equals to 2aq, knowing fully well that dipole moment is dip is q, that's charge multiplied by what? By the distance. So that's the answer for the second question. Number three question, we have two equal and opposite charges of a magnitude. We have the magnitude respectively 2 times 10 raised to power minus 7, and they are minus 7 coulomb, and it is 15 centimeter apart. So we are asked to find the magnitude and the direction of the electric field midway between the charges. Now note the word electric field midway between the charges. Now there are two different ways you can solve this. Is either you solve by dividing the distance by 2, or you just solve it directly. Is either you solve it by dividing the distance by 2, and at the end of the day you multiply the electric field by 2, you will still arrive at the same answer, or you just go directly by finding the electric field. So our electric field, since the question is saying you should find the magnitude and the direction of the electric field, so you just solve the electric field in whole. Do you understand? So you have K to be 9 times 10 raised to power 9 times the charge, right? Times the charge, which is 2 times 10 raised to power minus 7, over the distance apart. You convert the distance to meters, so we have 0.15 squared, and at the end of the day we arrive at our final answer as 6.4 times 10 raised to power 5 coulombs. We have Newton coulomb, sorry. So 6.4 times 10 raised to power 5 Newton coulomb towards the positive charge. Now the reason why it is towards the positive charge is because since the charges are equal and opposite, so it simply means that when you take the net electric field, when you add the two charges together, you are going to have, they will cancel each other. So the net electric field in this case will be equals to 0. Sure you get? So we have the net electric field to be equals to 0, but that's not what they want us to find. They only want us to find the electric field along the positive charge only. Assuming you arrive at a negative answer, it simply means that it's going to be towards the negative charge. So that's that for question number 4. So quickly, let's move down to question number 4. So question number 4 says that 2-point charges of magnitude 2 times 10 raised to power minus 7 and coulombs, and 8.5 times 10 raised to power minus 8 coulomb, they are 2 centimeter apart. So we have two different charges, and the distance separating these two charges is 2 centimeter. So they want us to find the electric field that each of these charges produce. So it simply means that since the respective electric charges that each of these electric field that each of these charges is going to produce. Now there is a difference between electric field and electric charge and electric force. So these three things, they are different. There's a difference between electric field, electric force, and electric charge. So they want us to find the electric field that each of these electric charges produces, right? So it simply means that we are going to find the first electric charge and the second electric charge, knowing fully well that we'll be using E is equals to kq over r squared, and k is equals to 9 times 10 raised to power 9. That's the general constant for k. And respectively, we have the value for k for the first one, and we have the value for k for the second one. So when you insert the parameters given, you have our E1 to be 3.4 times 10 raised to power 5 Newton Coulomb, and the second one to be 1.35 times 10 raised to power 6 Newton Coulomb. So the last question for today's class. We have the last question, and the last question says that we should calculate the electric field at a distance of 0.2 meter from the positive charge, so along the dipole moment. So we have the dipole moment and the separation to be 20 centimeter. Now you notice that the electric field at a distance of 0.2 meter and a separation of 20 centimeters, so it simply means that we are having two different distance. So we have the first one 0.2 meter and the second one 20 centimeter. So we convert one of them to meter. So at the end of the day, we have the first one to be 1.8 times 10 raised to power 5 Newton Coulomb, and the second one to be minus 1.8. Now the reason why it is minus, because it is coming along the negative charge. It simply means that when you take the electric force, the net electric field, you'll be having the net electric field to be equals to 0. So respectively, we have our E1 to be positive 1.8 times 10 raised to power 5 Newton Coulomb, and the second one to be negative 1.8 times 10 raised to power 5 Newton Coulomb. So this is the end of this episode. So we'll move on to the next episode 5 questions to physics 102. Thank you.